So we'll do a few problems regarding the AC power. Find average power supplied by source if phasor is in terms of the maximum values. Okay. So that means not RMS but the maximum value. Now one suggestion I would give is always write your formula in the RMS terms only. And whatever maximum values are there, just convert it into the RMS. So for example, here if you take this voltage source as Vs, this is the only phasor that is given, right? So Vs is equal to 5 angle 30 degrees. This is in terms of the maximum value. So you can convert into RMS form as 5 by root 2 angle 30 degrees. So in this way you will have to remember only one type of formula, that is using the RMS value, what is the expression for power. Okay. Now here what did they ask? They asked the average power. So that means the real power. So what will be the real power? This is equal to I RMS square into R. Okay. So that means R you have here, we need to find out the current through this circuit. So let us take the current to be I. So I bar, it is going to be Vs divided by 4 minus J2. Now Vs if you take as the RMS value, then automatically I also you will get the RMS value. Since we want only the magnitude, so we will take only the magnitude. So this is going to be 5 by root 2 divided by root over 4 square plus 2 square. So this you are going to get as 1 by 2 root over 5 by 2. So now you can get the average power as I RMS square. So you will be getting 5 by 8 into the resistance value is 4. So you are going to get 2.5 watts. Next, find ZL value such that the maximum average power is delivered to it. So here you have ZL. Okay, so what you need to find? You need to find the Thevenin's resistance looking through these terminals. Okay, so what is the condition for? And then you can apply the condition. What is the condition? ZL is equal to ZTH conjugate. Okay, under this condition, maximum power, average power will be delivered. So in order to find ZTH, we have to turn off the independent sources. So we are shorting the voltage source. Here you have capacitor, this is 8 ohm minus J6 ohm, J5 ohm, and through these terminals you have to find out ZTH. Okay. So what are you getting here? ZTH is equal to J5 is in series with the 4 ohm parallel to 8 minus J6. The final answer you are going to get 2.93 plus J4.46. Therefore, what should be the value of ZL? This is equal to ZTH conjugate, which is equal to 2.93 minus J4.46 ohms. Next question. Find RL for maximum average power to be absorbed by it. Okay. So here we have RL. So you can see that this is a condition where there is no reactance. Load reactance is not present. Okay. So in that case, what is the condition? So we already derived it. RL should be equal to mod ZTH. Okay. So now what is ZTH? You have to Thevenin's resistance by looking through the RL terminals. Okay. And here I have shorted the independent voltage source. So from here you have to see this is going to be ZTH. This is minus J30 ohms, 90 ohms, 80 ohms and J60 ohms. Okay. So you can see that there are 3 branches in parallel. So what you are going to get? ZTH is equal to 80 plus J60, they are in series, which is in parallel to 90, which is in parallel to minus J30. This you are going to get 29.9 angle minus 55.05. Okay, but we are only concerned with the magnitude because RL should be equal to the magnitude of ZTH. So RL is equal to 29.9 ohms or approximately 30 ohms. Next question, voltage across a load is V of t is equal to 60 cos omega t minus 10 degrees and current I of t is equal to 1.5 cos omega t plus 50 degrees. Find the following. You have three different bits. First is complex and apparent power, next real and reactive power, finally power factor and load impedance. So we will see how to do this. You can pause the video and you can try for yourself and see the final answer. So according to the question, there is a load across which the voltage is given by V of t and the current flowing through it is I of t. Okay. So now we know I of t and V of t. So we will write it in the phasor form. So what will be V bar? You can see that both are in cos forms. So we can directly write without any problem. 60 angle minus 10 degrees. This is in terms of the maximum values. So you can also write in terms of RMS as 60 by root 2 minus angle 10. So we will prefer to deal with the RMS values. What is I bar? This is going to be 1.5 by root 2 angle 50 degrees. So this is also we have taken in RMS. Next, complex, first bit is complex and apparent power. So we need S and the magnitude of S. Okay. So what is S? This is equal to V bar I bar conjugate. Okay. So what is this? 60 by root 2 angle minus 10 into I bar conjugate is 1 by 5 root 2, angle will become minus 50 degrees. So this you are going to get 45 angle minus 60 degrees. What is the unit here? Volt ampere. Okay. Now what about this is what? Complex power. Next is apparent power. This is just the magnitude of complex power. So this is equal to mod S is equal to 45 volt ampere. Okay. So this is the first question. What is the second question? You have to find the real and reactive power. So what is the real and reactive power? This is real power is represented by P and the reactive power is represented by Q. So these you can either find from voltage and current, that is VI cos phi, or you can also find as the complex power into cos phi. Okay. So what is S? 45 and cos of minus 60 degrees. So this is going to be 22.5. What is the units here? Watts. And what about Q? This is going to be S sin phi. So 45 into sine of minus 60. Okay. So this you are going to get minus 38.97 volt ampere reactive. That is the unit. Okay. So what you can observe here, Q is negative. What is the conclusion if Q is negative? We have discussed it means that it is a capacitive load. And finally, the last question is you have to find the power factor and load impedance. So we know the power factor angle. What is the power factor angle? It is given, it is the same as the angle of complex power, which is minus 60, right? So power factor is equal to cos of minus 60. Okay. Since angle is positive, it means it is a leading power factor. Okay. Since cos of theta or cos of minus theta, both of them will give you cos theta only. Okay. So it is important to mention whether it is a leading load or a lagging load. Okay. So you're going to get 0.5 leading. Okay. So this is the correct way of representing the power factor. And finally, the load impedance. So how to find out the load impedance? This is simply the voltage phasor divided by the current phasor. So here you can take either the maximum or the RMS values because they will get cancelled. Okay. 60 by root 2 angle minus 10 degrees divided by 1.5 by root 2 angle 50 degrees. So how much you're going to get here? 40 angle minus 60 degrees. You can see that the angle is same as the angle for complex power, right?